Let's begin. So we're in the process of rewriting the backend, changing it a tiny bit, moving from texture 2D to compute buffers for the underlying terrain data. I think it has gone pretty good so far. Hopefully we can close it up today-ish. We know that everything works, the data gets sent in the correct way to the GPU and we unpack it in the correct way and we can utilize it on the GPU. Now we just have to make sure that some of the tools we had previously still work with the terrain system. So for instance, the Terraform marker, previously we did it with a Blit solution, so entirely on the GPU. I'm not confident in compute buffers fully just yet to do it fully on the GPU, so we're re-implementing the CPU approach to it. I think it's a good idea to have both, and that's pretty much where we're at. What's up, Gigi, Sammy, and good morning, Geralt. So let's take a look here. We can currently... Oh, we can actually... Oh, yeah, we have two problems. We can currently change the values on the GPU, but we have a little bit of a constraint here. We can only do it like this, pretty much. And we also... the brush we use, we don't read it in the correct way. I don't know if there's if these two errors depend on each other or not. Because actually, if we do this, if we change this one to 0, then it works. So we use brush 0, which is just pure white. Then we can change it everywhere. We can add as well, but if we... So adding here works, but if we use a brush that is a little bit more, not just pure white, but circular white, like this, then we get... so we should be getting like a circular result here, but what we get instead is this. So we can see here that the offset isn't really correct. We would like to have this one here. The lightest part should be here, and then we reduce the amount towards the edges of the marker. Interesting. Okay. And for everything to work here, we utilize something called Terraform data. It's a class, could pretty much work as a struct as well, I think. So when the player selects a spot and starts a Terraform action, we calculate, based on the Terraform brush and some other parameters, we calculate some data that describes the area we're currently terraforming. So vectors for bounds, clamped bounds, and on and on and on it goes. I would say that the theory behind it, or the idea behind this, is pretty straightforward, but with so many other things, it becomes real complicated when you dig into it, because you have a lot of different parameters affecting this one, but the most important part, or the hardest part, I would say, is that you have a lot of transformation between spaces as well. So much like you usually do in shaders and object space, world space, here we have object space, world space, texture space, and maybe even more. So it all comes down to, or it all becomes a problem of properly mapping between these spaces. And I drew it real quick yesterday. I'm gonna draw it real quick again today. So we have a terrain base that consists of 4 terrain patches. We have a marker that's positioned here. So if this is our terraform data, that means that we want to terraform the bottom right of this patch, the top right of this patch, the top left of this patch, and the bottom left of this patch. And then you have a lot of different coordinate systems here, so you have indexing as well. So a point at each patch is explained in an, or represented by an XY. Which means that I don't remember exactly how we solved it, but I think we have, so we have a start coordinate here and an end coordinate here, and we overflow these, but then when we create the terrain patch specific terraform data, we fix the indices. But that's not important. I'm pretty sure that part works. What doesn't work, however, is this square here. And this is pretty much where we want to put our terraform texture, so brush texture. So let's visualize it by a circle right now, because that's what we have. So when we read, or when we want to set this pixel of this patch, we need to get the corresponding pixel from the brush. And so when we work with indices here, it's XY int based, so 0, 0, 1, 0, 2, 0, and so on. And rows, you go up in the Y indexing. When we work with the terraform brush, we're using the classical UV, so normalized coordinates between 0 and 1. So 0, 0 down here, 1, 1 up here. So given this boundary and this index, we need to transform it into this boundary and to a normalized coordinate. And I thought we had that fixed yesterday. Basically, what we do is, we do, we have bottom left, which is this point of the full marker. We have top right, which is this point of the full marker, and then we have bottom left clamp and top right clamped. So that's per terrain patch, that's clamped to this. We're gonna double check, so that's the case. Bounds depends on which bounds we send in, I reckon. So terraform data, we create it here. Alter terrain data, terraform data. We have already created it here, so let's go action terraform, terrain patch terraformers, terrain patch terraformer, terrain patch generates terraform data. And the bounds we send in are patch bounds, so that's good. That's beautiful, so that's exactly what we want. So when we have made sure that the things are what we think, why doesn't this one work? It might very well be that this method is correct, but the things we call it with might be wrong. Bottom left, top right. Yeah, okay, that's it. No, it's not. Yeah, it's something wrong here. So let's see here. Bottom left X, top right X, bottom left Y, top right Y. Okay, so that's one issue. Let's see if that was the culprit for it. For the total error we got. Might very well be, would be amazing. Okay, foliage. Let's make this big. Let's do -1. Okay. Let's do 1 and let's make it small. That looks pretty good, honestly. This 2 and this 2, this 2. So I just want to check. Let's remove it all. And let's add 1. I think that's about it. Beautiful, and I think we can check. Let's see if we can terraform it as well. I think so. Let's see. This looks pretty good to me. Let's make the terrain big again. Oh, fucking beautiful. Let's make the terrain big again. Let's try different terrain patches as well. So multiple terrain patches, and let's see what we have. So let's go with, I think the default was 128.256. So let's go with 256, 512, and we subdivide once. So we should get 4 terrain patches. Yeah, Catboy King and GG Sammy, pretty nice. Went pretty smoothly. A little bit worried about this performance, but we have some performance things to make. I'm guessing it's the water that's the culprit, mostly. Actually, no. 160. Do we have that many? Terrain patch. Was that resolution 256? Let's do this. Environmental, subdivide it once more. Yeah, I think we're not gonna work with water for quite a while again, or maybe first next week, so we might... Yeah, let's fix an offset on runtime after this one, or remove it altogether. Okay, now we have a way better performance, that's good. So we split it up in 4x4. Okay-ish resolution, would probably want better eventually, but... okay, so here we have... so this is between two patches, and if we terraform it, we can see that we actually have... Yeah, we have good transition between patches as well, so that's really good. How bad is this one right now? It's not too bad. Performance-wise, we get a little bit of a frame drop, but it's not too bad. And we haven't even started to optimize it, so that's good. Cool. Very nice. Okay. Yo, what's up, Coolers K? Do you really have to ask that question? It's extremely cool, my man. Wow, okay. So this is actually done now. Mostly. Let's see what we can do. We can probably fix it quite a lot as well. I'm actually quite surprised by the performance of the Terraform so far, especially since we haven't really done anything to make it optimized. So basically what we do when we terraform this big area, this one, we calculate all the points involved in it, and then we loop through them the classical way on the CPU with just a simple double nested for loop. That's pretty much it. We set the correct values in the structs we have, and then we send it down to the GPU. Don't make it too cool. Actually, that's something I've been starting to ponder right now. We don't want to make... I don't want to constrain the hardware that can run this game too much, you know? Oh, you mean it like that? We're actually gonna make ice eventually. So maybe I do want to make it cool. Too cool. Wow, I'm actually surprised how painless this actually was. We pretty much changed this entire class. We took the full terrain data, rewrote it, introduced a new class, so a new struct, a new class, made roughly the same entry and exit points, and it pretty much works with the current system we have. I had this idea. I think I'm gonna add it to the to-do. We have a lot of different classes here. We have Terraform data type, which defines the... It's like the atom almost. It's like the or what people thought atoms were previously. It's the smallest building block, pretty much. It defines, it's the base definition of the data we want to store. We have some nice methods for it. Then we have terrain data, so it's this struct and this pair. Then we have, I'm gonna bring in environment controller here as well. We have environment controller, which is our singleton, which holds and control anything environment related, and in this case also terrain base, which is the parent class of the terrain. This one holds terrain patches. Terrain patches holds a set of, it holds terrain data, one terrain patch data I mean. It also holds terrain patch meshes. Currently we only have 2. We probably, at most, I think we're gonna have 3. So ground, water, and weather related. I don't know if that's snow or whatever. Leaves maybe, I don't know. So terrain patch mesh comes with terrain patch mesh data. This is basically just the definition of what terrain patch meshes contains. But anyway, terrain patch also holds terrain patch data, and terrain patch data holds a set of terrain data buffers. It's a lot. It feels a little bit all over the place. We might combine some of these and stuff like that. And the one that I have in my sights to be the first for this is terrain patch data. Basically what it is, it's just a layer between terrain patch and the actual terrain patch data, and I think it's unnecessary. So while this one holds an array of terrain data buffers, what's to say that this one can't just hold a set of terrain? No, not this one, but this one. So we would replace this one with terrain data buffers. I think that's the correct call to make. But let's see here. I want to do some commits right now. We have a lot of changes. Definitely. So let's start today with committing some stuff, and then we commit it, we clean it up a bit, and then we can start extending it. And when I say extending it, I think I want to start experimenting with terrain activity data. Although I am a little bit worried about the performance of this one, but yeah, we can do it. One thing, do we have working grass currently? Okay, we can paint grass. Let's see here. I thought. Oh, have I? Yeah. We can paint grass, but we don't show it as for now. definitely want to update that one as well. Okay, let's do it like this. Terrain patch. Let's start by doing instantiate water mesh, transform local position. Let's bring it down instead. Let's sweep a 1 so we don't get that one interfering anymore. And then I want to do terrain patch data. Is it here? Generate data, generator, terrain data, generate data, foliage. Let's do height instead here. Apply data, height. So we generate the height. We don't care about foliage. Okay, yeah, that's good to know. We want to rework the initial generation so that we get overlapping here. Okay, that's good to know. This works. We get full 0 values here. Can we add some grass? Okay, why can't I seem to add grass these days? What the fuck, didn't we just have this one working? I wonder if try and patch data this one. Set data in material. Should be okay. Yes, okay, it's probably apply data update buffer. Do we apply it accordingly? I'm wondering if these two... I want to get to the bottom if these two calls does something that we don't do otherwise. Okay, it generates it, but we still can't. Okay, we have a little bit of a mismatch going on because here we don't get the updated data. Okay, so it's probably it's going to be extremely important when and where we do this one. Set data in material, apply data type. Oh yeah. Terraform brush type. Foliage. We alter the value in the correct places. We update buffer. And here we do set data. Okay, I might know what's going on. We don't update the textures themselves currently. But why not? Now it works. Okay, this is interesting. So when we subdivide, it doesn't. Okay, nice to get to the bottom of what's causing this, but why? So when we subdivide the terrain, we'll get a little bit of a problem. Okay. Why? Let's take a look at this one. I wonder, it shouldn't really matter. They should be able to share the name because we're doing, so different materials have different buffers, but they pretty much share the name. Yeah, that shouldn't be it. Yo, what's up, Derek? So why? Antoine, sorry about the pronunciation if it's wrong. How long have you been developing this game / level? What is it now? 3 years, I think. I reckon it could be a few things that go wrong here. Let's just do some quick debugging. I just want to see if we enter here. So debug log, let's do terraforming terraform data dot terraforming terraform data patch. Don't we have one? Just want to see if we get to this one now that we have split it up into patches. I don't see why we wouldn't though. Foliage. Terraforming 115 minus 7, 115, 120. Do we get, if I do this, let's terraform it extremely big. We do it on all this. Do we get anywhere? No, we don't. So we definitely get to this one, but then we don't do anything. Alter value. I want to double check one thing. compute buffer. Debug label. Uses mode shows buffer default is compute buffer mode immutable. And let's take a look at this one and this one. Structured buffer. Okay, so this is how I get it there. Interesting. Structured buffer, raw, compute buffer type, byte, address buffer. What the fuck, couldn't we rely on this one instead? Okay, typeless R32. Would definitely like to see some examples of the use with this one. That is indexed in bytes. Whoa! But okay. What the fuck? What the fuck? Wowee. So we could probably do... We don't need to do this shit. We don't need to do... Okay. We don't need to do this. We just go by index, if it's byte, if I'm getting this correct. And that also means that this one doesn't have to be 1 or 4 bytes per se. Okay. But I wonder, shader model supported. Yeah, so we need to do... So if we use this byte address buffer instead, we're constraining it to shader model 5. Let's do this. Very interesting. Use... Where do we have it here? Compute buffer type. Raw. Use raw instead and work with the data as just instead. Might constrain supported hardware. Might opens up for non or removes 4 byte constraint on terrain data. Yeah, let's just leave it at that. Okay, that's very good to know. But anyway, this one we don't want to change now, but compute buffer mode. Static buffer, only initial upload allowed by the CPU. Unsynchronized, maybe we want this one eventually. Maybe when we are a little bit more confident in what we're doing, but this is pretty much what we want. We want to have dynamic buffers. We want to be able to change data and upload it to the GPU dynamically. What I'm wondering is what made this work when we run with when we only have one terrain patch it works, but when we have multiple it doesn't. But okay, so anyway, when we, let's quit this, let's see if this is the cause for the issues. But when we instantiate it, we want to do compute buffer type default, and then compute buffer mode, what the fuck, circular? Internal use only. Okay, dynamic. Okay, now we can't draw at all. And we don't even get the initial generation. Antoine, I haven't seen all of your code, but I wonder if it's nested instance. Explain, I'm listening. Now we don't get any data. I'm wondering if when we send the data to the GPU, terrain data, set data. Antoine, at one point the code only affected one area of the terrain or specific coordinates in the environment. So let me put it this way. Our terrain, we split it up in multiple patches usually. When we only have one patch, it works. When we have multiple patches, it doesn't. You might be onto something. Definitely, it might be a problem with let's see here. And we should have instance materials, but you never know. Okay, that explains it. A little bit. Why did it work with textures though? Which one is the first one? It's this one. I wonder if yeah, I think the problems, it's instance based definitely. For some reason we don't get instanced materials here, so they share the materials. So when we set the data, we set it for one of them, might lead to these issues. We need to instantiate the material or separate materials for, one sec. Separate materials for each patch, definitely. But we have, like, what boggles my mind is that we didn't do this when we worked with textures. It was pretty much done automatically. It's not now, however, so we might need to do it manually. One more thing. When we work with shaders or materials, we have cell shade lit, we have instanced properties. So pretty much we render multiple different objects with the same material, but we have one or a number of properties that differ between the materials. So way of optimizing, I guess. The thing was, previously you couldn't do instanced, so you can't instance textures. You can only do it with basic like floats and stuff like that. I wonder if you can do instanced compute buffers. Unity material instance properties. So let's see, instanced compute buffer. Buffers and instancing. I thought this wasn't possible. Texture array, exactly. I need to research this a bit more. Let's call it structured buffer. Would be amazing if this were the case, because that means if we render 16 terrain patches, they all use the same material, but they have different structured buffers. That would be beautiful. But I would find it a little bit weird if this is true, that it works for structured buffers, but not for textures. I wonder. But anyway, Antoine, I'm sorry about the pronunciation if it's wrong, by the way, but you're onto something with instanced. I think our materials now, when we set buffer instead of texture, we just get one instance of the material, so they are not differentiated, right? Harry-O, you would need to do the instancing manually. Yes, I wouldn't dare hope for anything else. The thing is, so previously, I think a couple of months back, probably more, before the summer, I think, we were writing the grass shader and we started implementing instanced properties in the grass shader. And quickly noticed that that were when we were using textures for our data, and you can't instance textures, so you can't have multiple, so you can't render multiple different objects using the same material. If you want to vary the texture between the objects, then it becomes multiple different materials. you would have to do it with a texture array in that case. I'm just wondering if it's the same for structured buffers or if we can actually instance it. Yeah, so if we give the material an offset integer and we instance the offset integer, then it's pretty much the same idea as a texture array, right? I'm just wondering if... Exactly. So that's one way to instance it, which is pretty much, yeah. So is that the only way to instance structured buffer properties? That's it. That is a bit unfortunate, I guess. I don't know if... Yeah, okay, I appreciate it. What I don't like with that is... I'm gonna have to think about it, but like one drawback I can think of right now is that I'm gonna have to research it and get back. But yeah. Gober, by the way, so much code, incredible. You're working on this solo if you are. Yeah, I'm currently. Best of luck and good morning from the USA. Good morning. Keep working hard. Yeah, I will try. But okay, yeah, we're gonna have to do some... I'm gonna have to do some research there on what path I want to take. Either... I think I can do that decision further down the line, because I think... let's get to it when we get to it. But okay, so when we... Let's see here, when we have a terrain patch and we call... we have set material somewhere, I think. So if you differentiate each texture wanted slow runtime, not really sure I know exactly what you mean, but yeah, that's the question. If we want to instance the properties, we will do it with the goal of optimizing runtime. Okay, terrain patch, material, material, instantiate, here we have ground material, water material, so I guess we would like to do dot, let's see here. One sec. Yeah, when we set the initial materials and then when we do... And then when we do... set material... And we're gonna rework this a bit, but let's see here. I want to create an instance. Or just copy it or whatever. Yeah, probably want to do this, I guess. Thought we would have a method for this. Okay, let's do this then. So we want to do it like... we do it like that. Appreciate it. So we do new material, ground material. Let's see if this is the cause of it. And I want to fix this in debug as well. So set material. Do you call this one anywhere? Yes, we do. Weather. Okay, that I'm okay with that one. And we do ground mesh, set material, enter in the set data in material, but we probably want to set this one first. When we did the exact same thing with textures instead, we didn't have this problem, or we didn't have to do this explicitly. I wonder why. Okay, that's good. Another problem, however, set material, terrain base. Here we do set material, and this is okay. Because now I have a problem. Instead, I have a problem of I can't change the debug mode of. We can only have this one. I wonder. Let's take a look at this one. Material Unity. I wonder. Constructors, source. We don't get, when we do it this way, material, we do new material, we don't get these settings. So we probably also need to do copy properties. We get a new instance of the material, the base material. Let's just try and do this as well and see if we get the correct stuff. So we do it here. Generate data, applied it. I don't think, yeah, when we instantiate, we might as well do it as this. Might be better to use material property block rather than separate material instances. Let's override only one property and keep the rest, including local keywords. Ooh. Yeah, definitely. I'm gonna do, let's do this. Nice description. Yes. Okay. When we do it here, I think it's okay that we do it like this, but I just want to see if this is the cause for the problem. So let's do material copy and copy properties from material. Let's see if we can properly visualize the properties this time around. Yes, we can. And what do we have here? That doesn't look too good. And what do we have here? Okay. Foliage. Still can't paint. I'm still wondering if we have some mismatch when we send the data. Yo, what's up, Spires? Thank you for the raid. You too. Okay, so when we send this data to the GPU, we have some sort of problem. This doesn't look good at all. And we only get it for one patch. We get it for the first patch. All of the other ones, they don't get any data at all. And we can't alter the data after the fact. Set data in material copy. Here we set the buffers. Terrain data type 2. I wonder first of all, the data is pure white, doesn't seem that good. That's not what we want. We can't alter this one. Can we alter? No, we can't. two issues. One, the apparent one, we can't alter the data. We don't transfer the data the correct way. Second issue, which I think is the weirdest, when we changed this one from using the default, so when we switched compute buffer mode to dynamic, instead of immutable, which is default, if I remember correctly, where do we have the compute buffer type? Yeah, default is immutable. So when we had this one, we could change it when we wanted. Only initial upload allowed by the CPU. Look at this. Let's see. One sec. Yeah. Immutable. Immutable environment. Let's go 128.256.0. We change the height data in real time. We change the foliage data in real time. And this is with immutable here. Am I missing something? The buffer is not modified, but the buffer, is it the values in the buffer or only the buffer properties? So why can I dynamically change the data here if I chose immutable? We shouldn't be able to do it after the fact, right? Use this if the buffer is modified often by the CPU, yeah. By calls to set data. Unity typically stores buffers this type. This is rough, however, but does this make any sense? One sec, just gonna grab a cup of coffee. Okay, back. This is weird as hell. Let me just try. I want to try immutable setup if we do multiple 256, 512, 2. If we do multiple material instances as well. What the fuck? Are you serious? Are you serious? Okay, this is how I want it to work. Looks beautiful, works beautiful. But what the fuck? GG Sammy, that was super fast. Yeah, I had one locked and loaded, so to speak. Compute buffer. New compute buffer with height, size, compute buffer type default, compute buffer mode immutable. Static buffer only initial upload allowed by the CPU. This together with this begs to differ, right? What am I missing? What I would like to have, this result, so I want it to work like it does now, but that's what I would assume compute buffer dynamic would allow for, not the other way around. Not the other way around. '21. Aero, I would ignore those docs. They're just straight up misinformation. Yeah, that seems to be the case. What can I trust these days if I even can't trust coding documentation, man? Immutable is the standard one, usually shouldn't need anything else. Yeah, what the fuck? Thank you so much for your knowledge, man. I really appreciate it, because this annoys me. This annoys me. We're delaying the doc fix for now. 21, Unity 6. We're delaying they delayed it for quite a while, it seems. Okay. This is extremely good to know. But I wonder, does the same go for... Am I gonna have problems when I eventually, if I do, let's see here, when I want to do... oh, come on. Can I trust the documentation when I eventually want to do, when I want to experiment with having different types here? So if, for instance, if I would like to have raw instead of default, can I trust this now? I don't know. But this one, extremely good to know. References. Compute buffer mode. Immutable. Hario, yes. Okay, thank you. Appreciate it. Compute buffer begin write is only for the sub updates buffer mode. Okay. Yeah, I might be a little bit too deep here. Hario, but if your PC is using DirectX, pretty much any type works for any type of operation. Okay, nice. Nah, it's just a question of if we eventually turn to using a struct here that has, or different type of structs here, one that it has 1 byte, for instance. I guess it doesn't really matter in the end. Yeah, maybe, actually it does. Because I guess, for instance, if we would like to have a structured buffer with values where we only have 1 byte and we want to represent it on the CPU side as a struct with a single byte, I wonder if also something I need to research, but I wonder if using byte address buffer on the GPU side of things would make it a little bit cleaner, maybe. Because if you do byte address buffer, you probably don't need to do byte shifts and masking and stuff like that on the GPU, right? You just add... yeah. But we'll see. Yeah, I'm gonna have to find the time and read this through, because I think this stuff is very interesting. But I guess what I can take away from this thread now is exactly what you said, Harry O. Don't trust the docs on this stuff. Go with immutable. Byte address buffer gives you a minimum of 4 bytes with each read too. I figured as much. But what I'm getting at is the pros would pretty much be that we could have, like if we have a structured buffer with only one value we want to store. So let's say that we want to have a buffer that is separate for only the height. We wouldn't need to handle the pairing of 4 bytes on the CPU here like this. So instead we just have a struct with 1 byte here, which simplifies things like this quite a lot. And then when we send it down to the GPU, it's a list of bytes, and we use byte address buffer, and yeah, it reads 4 byte at a time, but the whole process is way more simplified. Does this make any sense? So right now we pack it like this. We pack multiple different types of data in 32 bits, and it doesn't hurt us because we have some data that is relative to each other, so we might as well pack them together. But if we have one data type that is changed very frequently and is not related to any other data type, so we want to isolate that one, keep it in its own buffer, what we could do then is we could have a custom struct with just 1 byte in it, and we work with it as a byte address buffer from start to finish. Is this just rambling, or does it make sense? I guess in the end, as far as optimization goes, it's probably no difference, but it's a matter of not having to do this stuff on the CPU. Instead, we just set one value. Now it makes sense. That's how these skinned renderers work. Okay. Okay. I like this stuff. It's fun. Harry O, have 2 separate buffers, one for stuff that will be edited every frame and one which don't. Post normal tangent. Oh yeah. Okay, don't we have? Oh, I actually read about that pretty recently. Now I want to get to yes. But I think I was now when you say it, I read it recently. GG Sam, a random question. When you add additional lights to your scene, do you need to set any properties in it to work in the shader code? My get additional lights count returns 0 even though I have extra lights in my scene. No, I didn't, but you have some other settings. Where do we have that? You have some settings for additional lights here. So if in your settings, if you have additional lights disabled, if you have additional lights disabled here, I don't think it will get any additional lights. Could be that. I guess you're talking about the cell shader, right? Okay, but this is pretty nice. Even though we do some very basic nested loop iterations on the CPU, it's pretty quick. Yeah, the extra light works on other objects, but I will look into those settings. Oh, okay, then. What do we have? That sounds weird. What Unity version are you using, by the way? And are you doing it with shader graph or purely HLSL? Okay, let's see here. One thing that bothers me is after the initial data generation here, each patch gets its own. We go by UV coordinates here, so we have this mismatch between patches. I want to fix that. When we have fixed that, I want to commit what we got so far, and then I want to do one simple cleanup, and when we have done that, we can start extending this system by adding some sort of activity texture. Some sort of activity texture would be very nice. Let me just try one thing as well. 1024, that's quite big. Unit 6 shader graph. And everything has worked up to this point. Yeah, I don't know what might have changed. Yeah, I don't like this, but I don't know what might have changed in Unity 6 when it comes to that. Pretty damn good. I would like to be able to hold E here and just paint. Okay. So when we do the initial data, when we generate the initial data, we do it here, generate values. Yeah, we send in this. We send in UVs that are specific to the indexing. So we pretty much, when we generate data for a patch, we do it by index, so each patch gets a generation between 0 and 1 here in this one. So we use the same noise for each patch. So what we need to do is we need to send in something else here instead of that one. We could go with, or what I would like to go with is probably world position. We don't have access to world position here, however, in terrain data. So, yo, what's up, Diligence? So, what do we want to do instead, or how do we want to send that information? So pretty much currently when we're generating data for a terrain that looks like this, we generate the data with UVs starting, so for this patch we do 0, 0, 1, 0, and we do the same for this one, 0, 0, or 1, 1, 1, 1. So we would like to have, we would like to send UVs to the generation algorithm that spans the full terrain and not per patch. So we would probably like to have 0, 0 here and 1, 1 here, like this. World position would be very nice, and probably what we need to use. I do not want to this one shouldn't have to keep track of that, which means that when we send in the UV here, we could add states to this one. So when we generate the values for the first patch, we have state 0, then we increment something when we go in X, and we increment something when we go in Y. Not a big fan of that either, but that is probably the best way to go about it, actually. Or, never mind. Yeah, some sort of offsetting to this would probably be best. So when we generate values here, we always send in UV 0 and 1. But this generator generate value, we have UV offset. Yeah, we probably want to work with this one. Yes. So we just change UV offset per, we know that each patch goes between 0 and 1. Yes. So we should probably just be able to do, we generate the data here. Currently we use UV offset 0, instead we do UV offset, we send in fuck, we don't have any information here. Terrain base, no, the indices here. No. I thought, or don't we don't store it possibly. Yeah, we do. Terrain patch, subdivision, so we could use these indices. The terrain patches themselves don't know this index right now. Might as well. Yeah, we could probably do it like that. Let's do it. Can we do... And then we just do, hopefully it will be cast to vector 2 by default. Let's see, index, yes. So now we have an offset here which is zero to number of patches, same for Y, and that should hopefully fix it. You might wonder, yeah, fuck, not entirely. Not entirely. Which is probably because size x minus 1. So when we do the last when we generate the data for like the last index in y or x for one patch, that should be equal to its neighbor's first one. The offset is 0 for the first one, 1 for the other one. Is this correct? Size x? It depends on this. Environment, let me just 512. So it's 128. I think this is correct, but I wonder about this one. This should lead us to having I as 0 should result in 0, 0. So 0, 0. I'm wondering, do we never get 1 values here? This is just 1 in this case, so I don't see how it has to be this one. So let's say that we generate 128. Yeah, what the fuck? We never get to 1 here, right? This one goes to data length. If we maybe we do. If I is 128, we do modulus 128, so we get 0, which is correct. Okay, 127. So the last pixel I 127, we get 127 here. Divided by 127, that's 1. We should be getting an overlap. Unless yes, this is probably not a something I've done wrong. It's probably I wonder if we want periodic. Yeah, it's probably a matter of we get the correct coordinates, but it's not periodic, so we start from the beginning. Probably, I just want to try that one. Generator. True. Could it be? No. Am I thinking about it the wrong way now? Yeah, periodic should give worse results, right? If we have periodic, yeah, and we go above 1 in UV here, we should get this value. Actually, do we get the... we get the correct in X, but not in Y. Okay, that explains it. Did we have the same issue with non-periodic? Was it only in one direction? Okay, so it's only in X. It's only in X. y. UV scale, noise scale, vector 2 1, noise scale 10. Does this one screw it up? Okay. We still have it here. Not as visible, however. Terrain base, when we set the indices, it's correct. When we create new here, we send in index first in instantiate. We set this index is equal to index. And then we generate the data here, we send in index. Data noise, UV offset, UV scale, UV noise scale, periodic false. We just set these here. Select the function we want. Everything looks okay up to this point. We send the correct ones here. Oh. Wait, what's the difference here? Oh yeah, here we just do a noise scale singular. It should be okay. X, 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 Y, Y, Y. Looks to be all right here. UV, UV. So pretty much what it comes down to is this. Converting the one-dimensional index into two-dimensional normalized index pretty much, or coordinates. But I don't see anything wrong with this unless integer, integer. We cast it after, so this one should calculate fully first. But one sec. It might be... one sec. Do we work with scale and size? Because that might fuck it up. Terrain-based data. UV, no we don't. We needed this when we worked with textures. I wonder if we still need it. I don't think so. But it's also weird that only the X gets screwed up, so pretty sure. I hope this is the cause for it, but I don't think so. No. Also find it extremely weird that it's only in the X direction. What do we do different in the X direction? As opposed to Z. Oops. I might know. Maybe. Let's see. Could it be the initial? Now we have different data. Let's see here. Let's do a quick debug by changing terrain debug shader. Height. Okay, we have different data there. Okay, that's good to know. This is not good. It probably can't be anything but the initial data generation that screws it up. Because as soon as we change it enough, they're always the same. Okay, it's not okay. Yeah, I know why. That might be the case for when we alter it. I'm pretty sure it's this one, unfortunately. Or could it be? Okay, we might not have an issue here. That would be beautiful. So probably just initial data. Okay. So back to the old question, why X and not Z? Oh, do we have information display? Yeah, whatever. Could we get, but it still doesn't make sense that it's only X. That's what's bothering me. 0 divided by this. No, I don't get it, I don't get it. Yo, what's up, Ramsey? What's the difference between float 2 and vector 2? I don't know too much about the mathematics package which float 2 comes from in this case. The documentation for Unity Mathematics is not that great, to say the least. But in this case, I think it's just I remember somewhere reading that they just introduced float 2 in this package to make it more HLSL-like, but I'm not sure. So the reason we are working with float 2 here is because these functions needs it. Yeah. Fuck, yesterday we ended on a indexing problem, if I remember correctly. Yeah, we did. Looks like we're gonna end on an indexing problem today as well. It's not my strong suit. This one, however, I have no idea where it comes from. It could very well be. It could be that we generate it in the opposite way. Oh. So it might not be an indexing problem, but rather terrain base. We start at 0, 0 here. Plus so it might be this one that is wrong. We might want to go with, I just want to try this real quick. Instead of doing I here, let's just do, what is it, subdivision -1 minus I. So what I'm getting at is we generate them in a specific order, we give them indices based on that order, and then when we generate the noise, okay, it was not this. So the index, the offset we use, okay, I'm pretty sure though that, yeah, it's something of that sort, because, or is it? The indexing adds 1 to the offset when we, to the coordinates when we generate noise. Now we don't even have the same mismatch between patches. No, we don't. It has to be this one, right? What can I replace this one to try to check if it's this one? But what the fuck, if we do, let's pause this one. If we do terrain base ij, we just set 0 0 and we do 0 0 and periodic is equal to true and it's 1 in length. We should, if it's not an indexing problem, we should have no seams this time around. So each period is 1 and we go from 0 to 1 at all times. Offset is 0, so it's basically, this one is 0 0 1 1 0 0. No, actually 1 1, which means that UV are entirely in control. One period is equal to UV scale times noise scale. So 1 1. But we still have it, so yeah, it's an indexing problem, I think. But yeah, I'm gonna have to get to the bottom of this tomorrow. So we will start the extending the terrain data we have tomorrow. Might introduce the activity texture, which I refer to it as, but it's no longer a texture, and it's going to keep track of mainly activity. Yeah, I think we're going to begin with that one tomorrow. Pretty good progress today, even though ran into yet another indexing problem. But yeah, thank you so much for watching today, and have a great rest of the day. Peace.